So we will deal with problem B on first, of course, uh, sketching the free body diagram, as it is the most basic skill that you must be able to know in order to solve problems. We have this problem: a block of granite are to be hauled up a 15-degree slope, that is what you are seeing there, out of a quarry, and dirt is to be dumped into the quarry to fill up all the holes. Now, in the process, you do that by this is your granite blocks, and then you try to move that uh, in this direction by putting something on your bucket. So your bucket will try to pull this thing downwards, and then so as a consequence, since this is connected with a string, it will all move in this direction. Okay, so I'm hoping you get the gist of what will happen to the problem. I'm just going to erase that one. And okay, now the first thing that I would like to tell you, or ask you rather, is how many free body diagrams do you think we will make out of this? So if you are thinking that we create, or we need to create, two free body diagrams, you are correct. So the first free body diagram is for the loaded block of granite on the cart, and then the second free body diagram is on the bucket. So let's first deal with the free body diagram for the cart. Now, I want you to pay special attention, because I'm going to tell you something that will be very helpful in terms of where will you start in the free body diagram. Now, as you can see here in this illustration class, the very practical tip that I would like to give you is to always sketch first the weight, because the weight will always be from the center of mass of that body 1, and that will always be just straight yun na siya kas perminti. Padulong ra yun na siya sa ubos, because the weight is always towards the center of the earth. So regardless of whatever this angle is, the weight will always straight lang yun na siya paubos. So that's why a practical tip in order in creating a free body diagram is to start with the weight. Okay, that is downward, and take note there is another force that exists here, since there is a contact on your cart and the surface. So when I say on the surface, I'm talking about this one here. So since there is a contact on the surface and that object, there must be a normal force. So that, and the normal force also is always perpendicular or 90 degrees with respect to the surface. So I'm just gonna write here, weight always directed downward, always directed straight downward. So that's why I am saying nakshay unaha kay always sure jud ka o straight na siya. And then your normal force, by the way, I failed to label, this is our weight, and this is your normal force. Your normal force, on the other hand, is always 90 degrees or perpendicular, they mean the same thing, to the surface. To the surface. Because if you try to look into this class, by the way, if you try to look into this one, ba, mauman imong surface, no? Nara, wait lang ha, para di mo malibog. Okay, ana na lang. Firstly, so, ana na lang, no? Sige, para dili na ma-confuse. First that we work with is the weight, and then second is the normal force. Now, gikan sa imong normal force class, this is how I often do this. Gikan sa akong normal force, I am going to make a straight line, imaginary padulong sa ubos. Straight lang yun na siya from my normal force. And you will see later why I did that. Okay, so that's my imaginary line. And then take note that this angle here is 15 degrees, right? So that's very clear. It's given in the problem that that is 15 degrees. Now, why I extended from my normal force up until the imaginary dotted line here? Because I'm just going to rewrite the direction, I mean the position of this weight here. So this is my W. Okay, maybe on the other side. This is weight. Now, kung unsay angle nimo dira class, which in that case that is 15 degrees, automatically, and I will not prove that this is a consequence of the geometry of the problem, ang sulod ani nga angle between your weight and your imaginary nga gi-extend ako nga line is the same angle nga 15 degrees sab na siya. Automatically. So if you have problems na ingon ani ang iyang itsura, automatic di na ka mangita, ala asa man si 15, where is 15 degrees? Because 15 degrees will automatically lie between your weight and the imaginary line. Okay? So that's the thing that I would like to emphasize in that case. Now, kinsa pa man ang force, diba? The whole point of using free body diagram is to determine the forces. Now, what is the other force that exists here? Now, you also have your kinsa man kini force due na imuhang, diba? This is a cable or this is a string. So that means there is a tension force. And again, asa man ang tension force? So tension force, butang na to na siya dira. So that is parallel or para representing the string, no? Now, where is it directed? Diba? Unsaon nga to pagkuha sa direction ana? We simply ask where is it pulling with respect to the body. Kinsa man ang body nimo, kining imuhang block nga nasa cart. Where is this force tension tries to pull the object? Now take note, as I've said kanina, ibira na siya padulong diri kay mohagbong man ang block padulong diri sa ubos. So your tension force is pulling it towards the right. Hence the head direction nimo dapat ingunana ang imuhang direction sa imong T1. Okay? So, sige. Now, normally, diba, the next step is we write FBD for body 1. And so, we have the Cartesian plane here. Diba, kini man ang next step. Draw ni mong Cartesian plane. Kaya dira man nimo is what? This is where you will illustrate the forces. Pero, dili pa nato na kaya diretso, di ba? For body 1, kaya medyo halahiwi lagi na siya, sir. Murag, unsaon man na siya, sir, if that is the case. So, I am going to utilize what I had here in the upper portion para mas ninyo, masabtan nyo what will happen. Now, gikan ani, I'm just going to, to rewrite the forces. Basically, the two sketches, the same na siya, class. Kining diagram sa busog sa taas. So, kini unsa ganining force directed always downward. That is your, sama na siya nga force. I don't know why it's broken. That one there. That is your weight. Right? The force, weight. Now, naatay force, na since na may contact ang imong surface o kanang imong body dira na mag-exist ang imuhang normal force, and unsa ganito timan-an to sa normal force, it's always 90 degrees here, 90 degrees with respect sa imong surface, imong normal force. I'm just going to remove that one. Basta the point there is the normal force 90 degrees na sa imong surface. Now, sa kanito itong next nga buhaton, the next step is to draw the broken lines coming from our normal force. That one. So ako lang gihimong straight line ang gikan sa tong normal force. And why we did that? Because, as I've said, whatever the angle here, which in this case that is 15 degrees, the 15 degrees will always be found within the weight and katong gi-extend, the one you extended from the normal force nga line. So this is also your 15 degrees. And again, we know that force in the form of tension due to the string is going towards your right. So, I will call that T1 na lang. This is also T1. Okay? Now, unsaon man na nimo nga halahiwi man ka na siya, sir. So, yun na akong buhaton, class. So, take heed kaya. Kini akong gi-extend, I also extended that from the normal force because I have a motive in mind. I will make that actually my y-axis. And this one here, kini siya, class, mao ni akong himuon. Kana siya nga line nga kanang surface bitaw along with the string. I will make that as my x-axis. Because I have to, of course, diba, in my free body diagram, I have to represent it in x and y axis. Now, it's not very friendly to the eyes, right? Because it looks very difficult how to represent that in x and y axis. So basically, I will group this one. What will happen, class, is sa Bisaya pa, mura na ako nig ituyok na ko para inani akong sabot. Mura na ko ni siya og wait. Ituyok na ko ni siya. Ako siya matuyok. Maybe here, no. Precise. Okay. Nung naniun ako siya ba? From that, take note that I have to represent that in this manner. Naka-straight si X, naka-straight si Y. But if you try to check your free body diagram initially, not the final free body diagram, I'm talking about this one, there is some problem because hiwi imong X, hiwi imong Y. So, syempre, ang atong mabuhat ana niya is we try to rotate that one na mag-straight imong Y axis paubos. So, just like this one. Ngunani siya imong buhaton. Nakita nimo? So, basically, mao man yung original nga position. So, you try to rotate your axis. Pak. So, straight na imong y-axis. Ang tawa. Your y-axis is going down and your x-axis is going to the x direction. So, it will be very easy now to identify the forces. And for clarity, I will use different colors. So, kini siya class. Hindi akong i-highlight. Ang tawa. Mao ni ko mahimong y-axis as I've said ganina. Kini akong i-highlight in green, mao na ni akong mahimo na dayon nga x-axis. So gamiton gyud nato tong imagination ato no, lang ano man tong nganong maingon ana ang free body. So ato na siyang actually gi-rotate. Now when I do that, take note, weight akong unahon ha. Ang akong weight dili na siya straight sa final nga free body na ingon na siya. Diri ang direction, this is the direction of my weight. And you have to note that this one here is measured at as 15 degrees. Now, syempre, since the weight is situated on the third quadrant, it's not lying sa imong bitang quadrants, ay sa imong quadrants, sa imong x and y axis, na siya components. So, do not forget to note of the components. This will be my w sub x, and this will be my w sub y. So, I am done with weight. So, I'm just going to remove the color here. Okay. So, I'm done with weight. This one, this force. Kinsa pa man ang force nga naa, class. The second force that I'm going to illustrate in my free body is the N. So, asa man ang N ako? So, syempre, the N is directed upward. So, you can see in the free body. So, this is how I will represent my normal force on the free body diagram. Kinsa pa man nga force? Naa si T1. Asa man na si T1? So, naa siya it's on the x-axis and it's towards the right. So, my T1 will look like this. T1. So, this is my free body diagram for 1. Free body diagram for the mass 1, which in this case is the cart. So, unsa ganito itong gibuhat? Imagine lang class, nagikan ani, kini akong circle. Diba? Kay imo siyang gipa-rotate. That's why you get the illustration from above. Or, if you like to, maybe this will help you. Ako sana siyang i-group. Group. Right. So, yun ani man na siya class, diba, originally, ang problem. So, what we did is to rotate your axis. Kaya nga naman, unsa ganito atong motive or goal, ana. I wanted that straight normal force o katong the imaginary line that I created will become my y-axis here, and the surface with which it is moving, kanang imong inclined plane, will be my x-axis. Now, to do that, I will try to, sa man akong gusto buhaton. Kung gusto na ko na ma-x o y-axis na siya, ang akong buhaton kay ako silang i-rotate. Paana? Pareha ni ba? Kung gibuhat, patuyo ko na ko siya taman sa ang katoa mahimong y, kini siya nahimo na sa y-axis, kini siya nahimo ng x-axis. And so I was able to sketch dayon kini akong free body diagram ana easily. Okay, so I understand maybe ma-confuse man ni gamay, so balik-balika lang ninyong ninga video. And if you have questions, please do raise that on the face-to-face before our quiz. Alright? So I'm going to, alright, I think this is good. Now, let's proceed to FBD2. There is a pikas. Kaya may raman ni. 4, 2. Okay, the circle is very small. for 2. So this will be very easy. Nga naman, firstly, naaman ni siya mass, no? So unsa may force ganyaning nga always straight from that body to? We're talking about the bucket. Padulong na siya sa imuhang ubos. Unsa na siya na force? That is your weight. Now take note, your bucket is connected with the same string. Connected man, the same string ra gyapon na sila dira with your cart. So, naa na siya dapat tension nga force. Now, the question is, where is the direction of the tension? Balik ta ani. When you want to get the direction of your tension, as ito yung giingon, you simply ask, where is it pulling with respect to the body? Or where is it pulling that object or that body? Our body here is the bucket. So, asa man. This is your string here. Where is it pulling the body? Is it downward, upward? So clearly it's pulling upward, so the direction of your tension force is upward. So that is your T1. Why T1? Because basically they are the same string that is connected with the cart. Alright? So for my free body of mass 2, I simply have this one. It's very easy. By the way, do we have an X? A force on the X-axis for body 2? Diri Do you have any force there? Clearly, wala. Wala ga-exist na force dara, ano? So, our X and Y axis will simply have these two forces. The one in blue, which is the weight, is directed downward. And then tension 1 in red. I should have used, sorry, I have to switch the colors to be consistent. Okay, the weight will be downward still, of course. We're just changing the color, that is W. And your T1 is pulling the bucket upward, so it will have that direction. And that is T1. So that's your free body diagram for object 1 and object 2.